Hello and welcome to the first lab video tutorial for Bio170. I'm your instructor, Israel Del Toro, and today we're going to be going through a solution for the first lab. I'm going to walk you through each of the steps of downloading data, importing data, and doing a first couple of box plots and as well as a violin plot in RStudio today. All right, so the first thing you're going to want to do is go to the rstudio.lawrence.edu, and you're going to come up to a page like this, and you can just simply sign on to this page with your Lawrence ID and password. That'll give you an option now to create a new session by selecting New here, and it's going to pop up an RStudio console, which has three basic windows: your console, a global environment, and then this plotting window. Now what we want to do today is upload our RMD file, this R Markdown file that can be found in Moodle. So to do that, we're going to go ahead and go to Moodle, sign on, and you're going to get to a page that looks something like this. You're going to look for a folder with today's lab on it, Lab 1, and you're going to download the entire folder. Once you click download, it's going to go live in your temporary folder of downloads. I'm working on a Mac, so you might be working on a PC, so things might look a little bit different for you, but it shouldn't be too difficult to find either way. Once you've gotten Lab 1 downloaded, you can, in your downloads folder, you can find it here. You can see I've downloaded it before, but I'm just going to do it one more time. And I'm going to double click on it, and it's going to make a copy of it. It's going to go from a zip file to a regular folder. Okay. Now what we want to do is we want to move this regular folder out of our downloads file because it's a temporary folder to something that's a little bit more permanent. My suggestion would be to use the campus share folder. To do this, you're going to go to the U drive on your machine, go to campus share, go to biology, Bio170 Del Toro, and then you're going to see a folder with your name on it. I'm going to put today's lab in this share folder. Okay, so all I'm going to do is going to copy it and let's see, select it, copy it, and paste it over. And now you can see I have a copy of it, actually two copies of this lab in the campus share. You'll only have one. All right, I can close out of that. We know everything is backed up and great. And so now let's go back to our RStudio console. Sorry, I've opened up two here. Let me close this guy. Okay. You should be looking at something like this. What we're going to be looking for today, I'm going to try and zoom in a little bit here, make things a little bigger, okay, is we're going to go down to this Files tab on the bottom right-hand corner. You're going to select Files, Upload, and then you're going to choose the directory or that location on the machine or on the server where you've saved that file. So you're going to go choose directory, and then simply you're going to go to the class share folder, biology, Bio170 Del Toro. I saved mine in share. You would probably save yours in your individual folder, and then select the lab. Inside of this folder, you'll have two files, a PDF file and an RMD file. The extension .rmd stands for R Markdown. Okay, and this is what we're going to work with for the rest of the lab. So we're going to select that guy, click Open, select OK. And you're going to see that this RMD file has now populated the environment of this bottom right-hand corner. To look at the file, all we have to do is simply click on it, and it's going to automatically open up in a fourth window of the RStudio server. What's really nice about this is that we've gone ahead and standardized essentially what I'm looking for in everyone's lab. The first lines, the first series of lines 1 through 8, are just information about the file itself. For example, in line 3, you can edit it to put your name here in between these quotations. So I'm going to put I Del Toro. You can change today's date. Today is the 26th, but if you're on the 28th, for example, you might want to change that. And you can set the different types of outputs that you're going to want to have. Remember, our Markdown files are a nice, convenient way of putting all of your code, your analyses, and your outputs into a single file. So In this case, the output format that we're going for is an HTML document, and we also want a table of contents that'll help us organize the analyses that we run today. When working in R Markdown files, you're working in something called chunks, or a series of chunks. Chunks are delimited by this notation here. So here we have 3 chunks visible, and they all chunks start off with these forward marks, followed by not a parens, brackets, the letter R, so telling Markdown that this is an R document, close brackets, and all chunks are closed off again by these 3 primes. Okay. So that's a chunk, is the space between these 3 primes and the bracketed R. All of the code that you build will go in between these 2 in this highlighted area. So in this case, lines 11 and 12. The first thing that you'll notice is that this template data has a whole bunch of question marks on it. Question marks are really important in R because they give us supplementary information about different functions that you're going to be using. For example, if you wanted to use the function library, we would click question mark library and run that line. Now to run a line, we can highlight the line and do Command Enter if you are in a Mac, or you can also highlight the line and go to run selected lines. It'll do the exact same thing. Now when you run line 11 here that says question mark library, we get all of the supplementary information associated with that function in the bottom right hand console. And here we see all of the different arguments that can be placed into this particular function. Okay. You'll notice that today's lab consists of 5 different chunks. Each chunk is labeled in different ways. The first chunk, for example, is labeled by chunk 1, load libraries. That's just the title of the chunk. This is a level 1 heading, so it means is that it's preceded by a single hash mark. Okay, if we wanted to do a level 2 heading, you would want to do 2 hash marks. For example, question in the hash mark in this lab we will load data and plot data. Great. So this is just a way of annotating and leaving notes for yourself. I strongly encourage you to do this for all of your labs. Use the hashtags. Use them to leave little cheat sheet notes, anything that'll help you make use of your code later. All right, that's enough about codes. I'm going to switch places here. I'm going to switch files real quick. I'm going to go to my cheat sheet, which is a completed version of this lab, and we're simply going to go through the different functions that you're going to be working with. In chunk 1, we already said we were working with the library function, and this is how you use library. Library allows you to load in different packages in R. In this case, the 2 packages we're interested in downloading are ggplot and datasets. So all we have to do is run library ggplot2 and library datasets. Once these libraries are loaded, you can check that they're loaded by going to the Packages tab and scrolling down until you find ggplot and you'll see that ggplot2 now has a little check mark next to it. This means that this package has been loaded. If we went back up and looked for datasets, we also see a check mark there. That means that these 2 packages have been successfully loaded. In the next chunk, what I want you to do is load some data that's already built into R. And we're going to use this using the function data. If we click on data, we're going to see all of the different arguments that can go into this particular function. And the data set that we want to load in today is this data set called insect sprays. We click that and we'll see, we run this line, line 19, and we'll see that insect sprays is now populating this top right-hand corner. This is your global environment. This is where functions and data sets are all stored and saved. If you don't see insect sprays up here, it means that you haven't loaded that data set yet. All right, let's explore this data set in chunk 3. We're going to do this with 4 different functions: str, head, tail, and summary. All we want to do now is do str of the data set that we've loaded, insect sprays in this case. Let's run line 30 here. And we're going to see now that insect sprays is a data frame consisting of 72 observations and 2 variables. The 2 variables are count, so the number of insects counted under different treatments, and spray are those different treatments, levels A, B, C, D, E, and F. Okay? If we wanted to look at the actual data itself, we could type in insect sprays, and we're going to see all of the data. But sometimes looking at all of the data could be a little overwhelming, so we might just want to look at the first 6 observations. To do that, we use the function head. Head of insect sprays gives us only the first 6 observations. We can also check the last 6 observations by using tail. Tail of insect sprays shows us the last 6 observations. Another way to check this data set is to do a simple summary of it, and we're going to use the function summary of insect sprays. When running summary of insect sprays, we see just some really rough data on each of these variables. So for count, we see our minimum value, our maximum value, our median and mean, and for spray, we see the number of observations corresponding to the different categories. So each category, A through F, has 12 observations in it. Okay, let's see if we can build our first plot here. In chunk 4, we're going to use functions in the library ggplot2 to build a box plot. Okay, now in this box plot, we're going to use the same structure for building all ggplot plots from here on out. Always identifying our data set, and then AES stands for aesthetics of that data set. So you have to think carefully about what you want to plot on your x-axis and what you want to plot on your y-axis. In this case, our data set is going to come from insect sprays. On the x-axis, we want spray, which corresponds to the categories. And on the y-axis, we want count, the number of insects associated with that particular spray. The next thing you want to do is create a layer to ggplot. In this case, the type of plot that we want to make is a box plot. To do that, we're going to use the function geom_boxplot. When we run this line, or these 2 lines, 40 and 41, we're going to see our first plot come out. So now we have our first plot. On the x-axis, we have spray. On the y-axis, we have the count of insects associated with that particular treatment. Now we can start to look and see and visualize the data, look for some differences between groups. Okay? Think about what each of these box plots is showing. Think about what each of the lines mean. What do the little whisker plots mean? What do the points mean on this particular box plot? All right, the last thing I'm asking you to do is to think about building a violin plot, which is kind of similar to a box plot, but you'll see it looks a little different. And I also ask you to do one more thing, or a couple of additional things. First, create a violin plot using the dataset iris. Create a violin plot for sepal length with each species colored differently, and the color fill is going to be 50% transparent. I also ask you to change the y-axis from sepal.length to sepal length in millimeters, and then ultimately write out this entire markdown file. So to do this, the first thing we'll want to do is actually load the dataset, data iris. And if we look at iris, we can do some really quick exploration of it. Just by looking at iris, again, we have a data frame with 150 observations this time of 5 different variables: sepal length, width, petal width, and species. What I ask you to do is put species on the x-axis, sepal length on the y-axis, and color each of the violins by the species identification. I also ask you to change that color from fully non-transparent to 50% transparent, and we do that by changing the alpha value here in Geom Violin. Finally, I ask you to change the Y label from sepal.length to sepal length separated and then millimeters in parentheses. When we run these data sets here, lines 49 through 51, we're going to see our next plot appear. And so here we have it. This is what we're looking for. On the x-axis species, on the y-axis sepal length. Notice that the y-axis now has changed from sepal.length to separated words, and each of the species is colored differently with a slightly transparent violin filled in. So that's it. That's the solution for this week's lab. It shouldn't take too long to do. Let me know if you have any questions by posting either comments on this video or asking me in class. And that's all I got for you guys today. Thank you.